What? Water!
Oh, look!
Water!
Okay, in this scene we see that Dr. Jones stops the trolley by friction with his boot. So let's see if this makes sense. So we assume that the system Trolley Plus Traveler has a mass of 300 kilograms. We assume that the mass of Indiana Jones is 90 kilograms, and we estimate that the distance traveled is about 100 meters and the initial velocity is 40 kilometers per hour. The first thing we need to do is to change everything into the SI units, and the only thing that it's not in the SI unit so far is the velocity. So we change those 40 kilometers per hour into 11.1 meters per second. So first we want to calculate what is the energy that the system has. Well, because that's kinetic energy, it's just 1/2 of the mass of the system times its velocity squared. So it's 1/2 of 300 kilograms times 11.1 squared. And this gives us a number of 1.85 times 10 to the 4 joules, so 18,500 joules. That's the energy that they have. If they come to a halt after friction, it's because all that energy has to be dissipated, because energy has to be conserved, so it has to go somewhere. It is dissipated in the form of heat in the boot of Indiana Jones. Now, let's see if it is reasonable that by friction Indiana Jones stops the trolley. So let's calculate what's the energy dissipated by Dr. Jones and his boot, and to do that we have to assume what's the friction coefficient, and let's be generous, let's assume that it's the maximum that we can have. Let's say it is 1. But what is the force that Indiana Jones is doing? Well, the force of friction is mu times n, and n we can assimilate, it's just the weight of Indiana Jones, mg. So we can calculate what is that friction force, and because we know the distance which we estimate is 100 meters, we can calculate what is the dissipated energy by friction if that force is a constant force applied onto the trolley for those 100 meters. So that the work that that force does is going to be the force times the distance. So it is mu times n times those 100 meters. If we calculate now that work done by friction, we need to multiply the force of friction by the distance. That force of friction is mu times n, and we know that n is just mg. Then we can just multiply mu mg delta x. We assume that mu is 1, mass is 90 kilograms, g is 9.8 meters per second square, and the distance is 100 meters. We just do this multiplication and we get a value of 85,500 joules, which is larger than the energy that they had initially, the trolley plus passengers had initially. So if Indiana Jones can dissipate more energy than the one they had, then it is doable, it makes sense, and he can stop the trolley by just friction. Now look at this scene from the movie Superman and keep in mind torque and moment of inertia. If we assume that Superman is acting a force on the Earth, a constant force, during those 15 seconds that we have seen, I want you to calculate what is the total torque of that force and what is the actual force that he is doing in order to make the Earth stop its rotational motion.